this is Robin. So we will be discussing the GATE 2023 question from physics. So as you can see, before we start, the first we need to see which is the concept which is required for this question. So you can see in the side, if you look at the NPTEL lectures, you would have to look at this topic, mathematical physics, and the subtopic differential equation. So why differential equation? It would be very clear very soon. So if you read the question, you have to find the correct options which represent the linearly independent pair of the functions of real variable x. So in every option, there are two functions of x, and though you have to select the pairs which are linearly independent. So let's say both are y1 and y2. Now, you should know something which can tell you that the y1 and y2 are linearly independent. Now, the very first thing is, if you want to say they are linearly independent, so that means you can't write each of them as linear combination of each other. That's the one idea. But in terms of differential equation, if you remember, for example, you have this. So this, I am just recapitulating the concepts for you. So if you see, your y is a e to the power ix plus a b e to the power minus ix. You write this as the solution. But if you remember correctly, if this is y1, this is y2, you always write the general solution as linear combination of linearly independent solution. So that means the y1 and y2 has to be linearly independent. Now the condition for that, which we always use, is to write the Wronskian corresponding to this. Now this quantity is y1 and y2 in rows, and the derivatives of that in the next row. So if this is non-zero, then your y1 and y2 are linearly independent. So let's check it one by one for each option. So first option is e to the power ix and e to the power minus ix. So if you write the Wronskian, that would be I e to the power ix minus I e to the power minus ix. So if I take this multiplication, e to the power ix, e to the power minus ix, minus I, e to the power ix, e to the power minus ix, this would give me 1. So it is minus 2i, which is non-zero. So yes, the first option is very much correct. So let's highlight it by green. So this is the correct option. Now let's look at the option B. So B option is x and e to the power x, if I remember correctly. Yes. So let's write the Wronskian. Derivative 1 e to the power x and x e to the power x minus e to the power x. So this is in general non-zero quantity. So these are linearly independent. And if you remember, you always find the polynomial solution, you find the exponential. So these are the linearly independent quantities. Right. So B is also now. If you look at option C, that is 2 to the power x, 2 to the power minus 3 plus x. Now the one simple way is to check like this. So you can write it like this. Now clearly your y2 is 2 to the power minus 3 times y1. If this is y1, this is y2, then this is the thing. So the idea of writing the one as the linear combination gives these are the linearly dependent. Now word linear correctly means you write it as multiplication of something or sum of something, right? So that's what the linearly dependent means. So this is not the correct option. So let's mark it as red. Now last option that we are going to check is, now other method I want to highlight for this option C also, like this is one of the way, and the Wronskian, if you calculate, this is this, and the derivative is 2 to the power x natural log 2. Right, so this is nothing but ln 2 2 to the power minus 3 2 to the power 2x minus ln 2 2 to the power minus 3 2 to the power 2x. So these are same, this is 0, so that's another way. Now if you see D, it is this. You write the Wronskian for this. Cos x. So there is this way you can write it. This is very nice way. Now this is nothing but Euler formula, right? If you say it correctly, so this is 1, which is also non-zero. So this is also correct option. So what we would say, this is also the correct option. So you have option A, B and D as a multiple select answers. Thank you.